Hi, everyone. Can you guys hear me? It's good? Yes, awesome. Well, thank you so much for coming here, especially Friday evening. I am just thrilled to be here to present today. Before I go ahead and start, machine learning, future of cybersecurity, big question mark. I have a disclaimer to make. I am not from any vendor or any organization. My presentation is simply a brainchild of my research. I'm sure just like me, you all go to a lot of conferences and we all hear this buzzword that, hey, buy our products, we have machine learning, it's a magic. And so anyway, long story short, I started wondering a few years ago, I'm like, what is this machine learning? Because we have so many problems, right, in cybersecurity. So I'm sure a lot of people here, either they are SOC engineers, Security Operations Center, or they're analysts, right? And this is our job every day, looking at millions of packets, right, and looking for anomalous activity, right? It's truly finding a needle in a haystack problem. So by show of hand, if you can show me appreciation of this problem, that would be good. For Security Operations Center, awesome. Okay, so you guys exactly know the pain that we all go through. So I'm desperate. I'm so desperate to find a solution. So is machine learning is the solution? So we'll find out. So the agenda for today is industry hoopla. The goal is not to shut down any vendor. The vendors are great. They help us. But I just really want, from just simply a researcher perspective, I just wanted to know the truth behind the story. So we'll talk about the industry hoopla, what our visionaries are telling us, what's machine learning. I know it's Friday evening. You guys all came. I really appreciate it. I'm going to have a little spoiler. Machine learning is not a magic box. It's a lot of mathematics, a lot of statistics. But the great news is I am not going to go over that. So just going to give it easy. We will talk about it just to set the stage. So, and there's a ton of links that I'm going to show you where you can go and study. If you are having a hard time falling asleep, which I do sometimes, you can read about those algorithms. Oh, I am 100% sure you will fall asleep because it is a complex thing. Then we'll talk about cybersecurity attack landscape. Possible use cases we'll try to answer is machine learning is an answer. And what machine learning can do for us in the future, right? We all can improve, so is machine learning. And at the end, we are going to have conclusion. So that's the agenda for our presentation. Let's see. So industry hoopla, that's where we are going to start. We all go to news every morning, cybersecurity professionals, right? We are 100% aware that we all get hacked, right? Left and right, data breaches, data loss. Some of the greatest data breach we have is Yahoo, Marriott, Facebook, right? Apparently, it impacted countries' election, according to some people, right? So, oh my God, this is a big deal. It's no longer cybersecurity is a 2-people team, 5-people team in their basement, right? Companies are spending millions. We are estimating that by 2021, we are going to have a $6 trillion damages. Wow. 76 billion of illegal activities thanks to Bitcoin. This is all news headline, right? I'm not making this up. Only 10% of the cybersecurities are ever reported, cyber crimes, right? So this breaches that blows the mind, right? Like 500 million, 3 billion, I don't know, millions and billions, and they are only 10%, right? It's a fear of unknown. We don't know so many things, right? According to statistics, every 14 seconds we get hit by ransomware. Every one malicious email gets in for 302 emails. So this is really scary. And the largest DDoS attack was recorded was 1.7 terabits per second. Wow, just mind-blowing stuff. Lots of data, even 5-year-olds, 10-year-old are having Facebook accounts. Everybody's connected, lots of data, right? So we really need help. So let's go to the next one. I'm sure just like me, as I said, we go to the conferences and we see all this all these banners from the vendors. Hey, buy our products, right? We have high accuracy, no noise. And I know as a security operations center analyst or engineer or as a manager, we would love that. Because hours and hours we sit through this terminal looking for malicious activity. But here they are claiming that no update is ever needed. We can eliminate patches. Oh my God, that's a heaven for us, right? No patches, no vulnerabilities, right? They're saying no endpoints protected by our products has ever been breached. Machine learning and AI can replace people, right? These are some actual claims. Do we believe this? It sounds good. Maybe it is true. We'll find out. If you buy our products, you will have 29 times better productivity, and our tool will automatically detect and classifies. I want to buy this today, right now, right? Because we are in so much pain, and here these people are telling us we have best of the best. So let's get it, right? Well, unfortunately, they are not $10. They are not $100. They are into millions. But does it make sense? Right? We are smart people. Does it make sense to spend millions of dollars into these claims? So we'll find out. Okay, so now we have more smart people claiming they're visionaries, right? Machine learning. So Hawking said the development of full artificial intelligence could spell end of the human race. Well, a little aggressive, I think. Artificial intelligence could be the most likely cause of Third World War. Musk said that. Well, we all know Musk. The nation that leads in AI will be the ruler of the world. Putin said that. And our friend Bezos said we are at the beginning of the golden age of AI. So this is all great. We have a ton of problems. What vulnerabilities to patch, how to prioritize, whoever are the managers in the room by show of hand very quickly. We all know it is extremely hard to hire a very skilled cybersecurity professionals. So we have all this ton of problems, and people are saying we can help. So let's move on to machine learning then. So what's a machine learning? I don't want to go too deep into this, but one thing I want to make sure that I read lots of papers, went to conferences, presentation. People interchangeably use the word artificial intelligence and machine learning. I am here to tell you the truth that machine learning and artificial intelligence are not equivalent. Artificial intelligence is a huge umbrella. It's extremely complex. Like when I started researching this, I'm like, oh my God, what I got myself into. This is so complicated. And inside artificial intelligence umbrella, we have machine learning, which is a subset. So what artificial intelligence tells us that if given a machine, it can interpret the data, learn from this data, adapt to a different situation, and achieve specific goals. If machine can do all of this all by itself, that's artificial intelligence. I asked my 14-year-old that what's the artificial intelligence? And then she would say, oh, Alexa and Siri. Well, that's great. That's a very, very poor example of artificial intelligence. We have not, if artificial intelligence can be properly implemented, we have not seen that power yet, or we are yet to see that power. So what's a machine learning? Machine learning is, again, all mathematics, data mining, right? There's no magic. Please, if you don't get anything out of this presentation, get this. Machine learning is not a magic. It's not a silver bullet, right? So any machine can learn without being explicitly programmed. That's what machine learning is. So if given, so what machine learning does is with a huge data set, it builds the model of behaviors. And you need to train this model. Now, how would you train this model? Well, you need a lot of expertise. I'm not a SME for this. I'm not an expert. I need to go and find an expert and a good data to train this model. This is one of the biggest hurdles. And I don't know where to find these people. Do we know where to find artificial intelligence, machine learning experts? I don't know. I don't know where to go for that. So we all know that, you know, when we go home, we turn on the TV, the Netflix, YouTube, they show us whatever we saw before, right? And it makes a prediction, right? That's what the machine learning helps us with. Why do we need machine learning? For better predictions, prioritizing, and finding patterns. So these are the goals of machine learning. And again, machine learning is not just for cybersecurity. We are trying to find the application of machine learning into the cybersecurity, so how it can help. This slide is directly from SANS. The reason I use this slide, because as a security operations center analyst, every day we are faced with this problem. What happened? Why did the problem happen? Why did this attack happen? What will happen next? So there are a lot of decision making in our process. There's a lot of thinking going on. So, excuse me, machine learning can actually help us make a better decision if it works right, and it will help us automate that, how to make a better decision. So that's the hope. That's the goal we are driving towards. So there are a ton of machine learning types. I only want to quickly go over supervised learning and unsupervised learning. So supervised learning is how we learn. If I have a baby, a toddler, or preschooler, right, and if I want to tell him or her that, hey, this is a dog and this is a cat, so I, as an adult, I already know the answer that this is a dog and this is a cat, and I'm going to repeatedly show that picture to that toddler or preschooler again and again and again, and then by the time they go to preschool or kindergarten, when they see any cat or dog on the road or wherever in the neighborhood, they will know that yes, it is a cat and it is a dog, right? It's exactly the same way. The supervised learning, in this case, we have apples. So we are showing the machine that this is the raw data. It is structured, it is labeled. So when we say structured and labeled data, that means we know what that is. We already know this is an apple. But we are trying to teach this to a machine. The machine will build a model. It will need a lot of training data and training time and experts. So after we go through all of this and processing, eventually the machine will learn enough. So when we show the machine green apple, the machine will say, aha, this is an apple, even though it's a green color. So that's what this slide is talking about. So the example of supervised learning is classification. We can do a lot of pattern finding. So it can be very, very useful. So again, very weak example of classification that I have seen in cybersecurity is detecting a spam, whether this email is a spam or not. Last year I presented on ransomware. The year before we did phishing. So we talked about the telltale sign of a fish. How does the fish email looks like? How does the ransomware looks like? We need to know, right? If we need to detect this thing, we need to first understand how these things look like. So that's what this is. This is feature extraction, understanding what that is. So step number one, we provide the algorithm the label data to learn. And number two, we feed the new data and see if the machine has learned. Very, very simple. It is not simple. This is Friday evening, and I'm just giving you a very quick and dirty example, but this is complex things. Unsupervised learning is like when we become an adult. So supervised learning is like kiddish kind of thing. Unsupervised learning is like, okay, so I am in this world. I have no idea some of the things, what is going on. So I will use my experience, and I will use my previous data, maybe feature extraction, text extraction to understand what this is. So here we are feeding a machine apple, banana, and mangoes without telling the machine what that is, right? So then, again, the same process. It's going to go through interpretation, making models, going through different algorithms, processing. And over the time, please remember, this is not quick and easy. We need to give it a time. We need to give it a training time, the expert's opinion and feedback and all that. And eventually, the machine will correctly identify without you telling the machine that, yes, these are apples based on features and skin and texture and taste. These are bananas and these are mangoes. So is this the only two things in machine learning? No, as I said, it's very complex. So the next thing, I'm going to go to Internet Explorer because this is very hard to see. I just wanted you to see so you can appreciate, and we all can appreciate. Hang on one second. So you guys can see things better. Okay. Oh, it doesn't show. That's okay. Let's go back. Let's go with my slide. So supervised learning in the chart, if you guys can see, I had Internet Explorer up, but unfortunately it's not showing up. So supervised learning, unsupervised learning, semi-supervised learning, and reinforced learning.
Take a second.
Oh, okay, no worries. Oh, okay. Okay, perfect. So here, hopefully this is a little bit better. So semi-supervised learning is a mixture of both. It's a supervised learning, so some data are structured, some data we do know that this is malicious, and some we don't. So it's a mixture of things. And the last one is reinforced learning, which is like a feedback based. So it's like I give a candy to a child and then he does homework. Not a good idea, but just giving an example. This is the same way I'm constantly giving the machine of feedback. Yes, you got it. No, you did not get it. Yes, you got it. You did not get it. So this is a feedback system. So as you can see, and again, it is extremely complex. In each line, right, and please take time whenever you get time to go through this presentation, go through these links, and understand if you're more interested. So under supervised learning, under unsupervised learning, we have different categories. In supervised learning, we have classification and regression. We'll talk about it more. But the application of all of this is house prediction, house price prediction, or medical imaging, or market basket analysis, right? How people buying things, what things they are buying, right? Optimized marketing, driverless car. So please feel free to definitely take a look at that. So let's go back to our presentation. Oh, got it. Okay, awesome. This is another, I wanted to show you how complex this is. I know you cannot read. The goal is that you cannot read. The goal is just to appreciate how busy this slide is and how many more algorithms goes inside. So again, if I am a manager or officer, and if I want to implement machine learning for my issues, right, I cannot do this by myself. That's the whole point. It is complex. I need to get somebody who is smart enough to understand this. So this is the website that I got this from. The link is included. But on the top, it has a Python code. So again, we don't have a time to go through all of this thing, but it gives you the example of Microsoft Azure. This is deep learning, neural networks. Please do not mix everything up. Neural networks are, again, it's a deep learning, which is, again, a subset of machine learning, right? And then the data science encompasses all of that. So again, I'm not smart enough, whoever understands this material, we need their help to say, hey, I have this problem, I have this data set, I don't have people who can work on it, can you please help me to implement the right solution? So if we gather all of this thing, then it's a good idea. So yeah, please take a time to review all of this. As I said, it's just a ton of information. And within each algorithm, they have pros and cons. When can you use which algorithm? So it's a pretty good site. It's just it's hard to remember like all of this thing. Anyway, let's go back. Okay. So the goal of supervised learning is that I know what bad behavior looks like. The goal of unsupervised learning is that, oh, I think you look different. So that's the end statement. So the overall process of machine learning is that we get an input data, then we go through a training algorithm, it makes a model, then it helps us to make a prediction and prioritization. So I think that's enough on that one. So let's look at the cybersecurity attack landscape. So I went to this website, Domo, and the title was Data Never Sleeps, right? So what they were saying that in every minute, YouTube uploads 48 hours of videos, just in 1 minute. Google receives over 2 million search queries. I'm just reading off on the chart. Apple receives 47,000 app downloads per minute. Users share 3,600 photos per minute in Instagram. So that's a lot of data. And remember, this is only public data, right? This is available data, right? What about the dynamic web pages that we can never get to? What about the black sites that web crawlers can never get to? What about the dark net? What about the dark web, right? What about the unlinked sites? What about the non-HTML? The content is encoded in a different format. And what about the websites that have username and passwords? So long story short, this is a lot of data. That's a ton of data. And all of this data can do a ton of things, right? We can scan this data, we can sniff this data can be used for social engineering. People can use this data to do account takeovers. You guys know the whole story, right? Privilege escalation, we can try to, I don't know, phish people, spam it. We can infect them with malware, on ransomware, adware. The list goes on, right? And we can have denial of service attack. So where do we go? Like, where do we focus, right? That's our everyday question, that there is a lot going on. Everybody knows the cyber kill chain, right? So I'm not going to go through that. I'm just expecting that, we just know it. So at every single stage, reconnaissance, intrusion, privilege escalation, right? We need to understand the attacker's prior actions, their potential actions, their intent, their TTP, right? That's a tactics, techniques, and procedure. Long story short, weakness exists everywhere. What are we going to do, right, at every single stage? And on the top, we have a questions, right? We have a questions, which vulnerability should I patch first? Which intel should I trust? How does the endpoint attacks looks like? Which alert should I look at first? We need experts, we need data, right, to do all of this thing. We are going to spend some time on this slide. This is extremely long site. Again, I don't claim to be an expert in data mining, but this is the meat of machine learning. Once we understand this data mining, then we have a pretty good chance. So classification, it assigns items to target categories, right? Whether this is a spam or it's a not spam, whether this is a ransomware or it's not a ransomware, right? So we talked about the classification. The regression is identifying and analyzing the relationship between the variables. How one variable changes compared to the next, right? How the weight changes based on the money it's being paid. Right, silly example. The fraud detection, the house price prediction, the total amount of suspicious transactions per location, how much the customer will spend in a given sales season. All of these answers regression can give us. Now there is error between regression, estimation, and prediction because they're all interrelated. Regression by itself cannot do much. Prediction by itself cannot do much, so we have to combine. And again, this is all mathematics, right? There are a lot of formulas, right, associated with that. Clustering is my favorite. It groups the similar data together into clusters and understand the differences and similarities between the data. So let's say that if I want to implement a solution that when the files go out of my network, how do I separate the legal data versus the outliers? So clustering is a great technique that we want to use in. And again, you will need an expert to recommend all this thing, whether you use association rules or regression or prediction or classification. And remember that website that I showed you? Based on the category you choose, there are 20, 30 other algorithms that you have to pick from. So this is a huge catalog that you need to pick from. Netflix and SoundCloud recommends the movie and songs preferences. So we can use the same thing for deciding that, okay, every time we have this attack, this is our response. So we can mix and match, right? So we can use this technique to help us with that, right? Or help us with making it false positive with a confidence. When I was a security operations center analyst, I spent hours and hours. I'm like, is this a false positive? What if it's a true attack, right? That's such a hard question, because if it's a true attack and I let it go, the company gets hacked, right? And I didn't do any, I mean, that's a guilt factor that I didn't do anything about. Or what about risk management? Companies spend millions of dollars. What if we have a tool where it automatically assigns the risk factor to the new vulnerabilities that we find every day? right? So we should have a system, new vulnerabilities, high, medium, low, and based on that, okay, these are the actions we're gonna take. Wouldn't our life be so much easier than having thousands of meetings? Well, I'm exaggerating. 8 hours worth of meeting every day and still discussing the same thing again and again and again. I think that will be fantastic if we can come up with something like this. And the association rules are finding all items that are frequently purchased together, like peanut butter jelly. There was a joke on Facebook, I'm gonna pass on that, but that was funny. The guy orders the stool, and then they recommend something else to go with it. It's just a joke. So what are some of the other areas that we can use the machine learning? So network protection. We can use regression to predict the network packet parameters and compare with the real one. Does this make sense? Classification to identify spoofing, or is it a scan? Is it a ransomware, right? We talked about that. We can use clustering for forensic analysis. I was trying to figure out who in a real life, so I interviewed a lot of people, who uses this for this kind of problems. I haven't found anyone. They use all these shiny tools that they get from vendor, and please do. I'm not saying don't buy tools. Buy tools. They're much better than having a human person, right, and going through all of that. So definitely whatever makes sense for your company, please do that. But make sure that it's an intelligent decision, and make sure what problems that you are trying to solve for which tool feature. For the endpoint protection, we can use regression to predict the next system call for execution and compare it with the real ones. We can do clustering to separate file attachments. For application security, we can use regression to detect the anomalies based on HTTP request. We can use clustering for DDoS attacks. I know we all buy expensive tools like Arbor, millions of dollars, but let's look at the data, what we have. Does this making sense, right? Always ask that question. For user behavior, this user is logging today on Sunday evening. Why? Do we have a tool like that? Right? So regression can help us for that. Let's say process behavior, right? For fraud detection, we can use regression. Again, clustering for the outliers, classification to detect the fraud. So please use these tools. It is extremely powerful, right? Power comes with a great responsibility, right? Great power comes with a great responsibility. Please definitely use this tool, but please make sure where do you use it? Do you have right people, right circumstances to use it? Okay, so where can we use, after all, these are all different vendors that I have found. Again, a disclaimer, I'm not recommending anyone. I have not purchased this because I'm not rich enough to pay millions of dollars to them. I have not evaluated any of these vendors. It is just that some of the vendors that I have found, according to me, there are 5 things that machine learning can help in cybersecurity. So network and threat identification, whether this is a real threat or not. DLP, that's a data loss prevention. Malware detection, email chatbot, or user behavior modeling. So I don't know if you guys use Darktrace, but that's the only one tool that I have found. By show of hands, I'm just curious, how many people use Darktrace? And it's very expensive, very, very expensive. So what Darktrace claims that you just plug me in, so I'm pretending as I'm a Darktrace machine, plug me in, and in 7 days I will be trained, and then I will know exactly what's a normal activity is and what's an anomalous activity is. Do we believe that? What if I plug in the machine into a hacked environment where everything is bad, right? If you teach your children bad things, they're gonna think the bad things are normal things, right? So we have to be very careful how we deploy this thing. So in network and threat identification, I found this vendor ShieldX, identifying which security policies are applicable for each application. For Versailles, it is a use of anomaly detection to identify network security attacks. And let's see, what else did I find? BlackBerry, Demisto, they automates the threat response. I love it. If this works, we can just go have a coffee and just sit and relax and just wait for 8 hours, right? And we're all done. That will be awesome if this tool can. And again, I have not analyzed, but I am curious. I'm seriously curious how effective these tools are. For DLP, I found Bay Dynamics and Symantec. They're saying they have a data loss prevention that uses ML. Again, no vendor will tell you that they use classification or regression or association rules, or what is their secret sauce. We don't know, right? What they use. They use something, right? And how effective it is, we don't know. So for email, for the antivirus, smart antivirus, they use AI to predict, detect, and respond to cybersecurity threats. And this list is just long. Harvest.ai, McAfee, so for Symantec, Trend Micro, Splunk, WebRoot, Chronicle, Mobile Iron, and yeah, that's it. They claim that they do malware detection based on machine learning. So yeah, please feel free to go and evaluate them. Let's say what else. Email, NoMail, Agari, and Inventa. That's what they claim. User behavior, we already talked about that. So long story short, what do we want these vendors to do? What are we looking for? So I thought that maybe we want to have pattern recognition to identify malware. Maybe we want to look for anomaly detection to detect unusual activity, data, and processes. We want to also have a natural language processing. I did not cover that in this presentation, but that's okay. All that is to convert the unstructured text into structured, intelligent data. So maybe we can use all of this in combination to look at how they can help us. And also, we need to have criteria, right? Like, how are we going to define the success? So whenever you evaluate a vendor, please also look at that as well. I just had this slide as a sample, just to see that how much goes into just to decide. And there is a site towards the end that tells you, and that will give you more information. But you have to look at byte sequence, API, system call, opcode, network, file system check, CPU registers. That's a lot of parameter goes into just deciding, okay, well, this is malware or not. The second slide I have that talks about whether this email is a spam or not. So first they do processing, they do feature extraction, they go through training, then they have machine learning model, and eventually the machine learns whether this is a spam or not. So again, this is an involved process. It's not quick and easy, right? There's a lot that goes through that. This was very interesting paper I found. So they said, let's think like a hacker. Why don't we just monitor dark web and dark net and figure out the threats, right? And then we'll do the mitigating controls according to that, right? So I'm not going to go through the whole paper, but I just thought that that paper was very interesting. So here they talk about, oh, I don't see, okay. Well, there is a website in my presentation, and I'm just going to read through that. So in this whole data, I know you guys cannot read it, but this is the only portion that's machine learning. So look at in the entire process how little the machine learning is, right? It's not the whole thing, right? Because you need to extract the data. Let me just read it. It's really cool how they do it. I'm sorry you guys cannot see this website. But first they do extraction of the data, right? They use the web crawler to extract the data from the darknet. Then they parse through this data. Then they clean the data. Then they label the data, right? Because the machine needs to know that, right? And after all of that, the machine learning parts comes tiny bit. So after testing, reviewing, training, experts' opinion, whatever, after it goes through all of that, you go through machine learning, then you are done, then you do test and review, then you parse the classified data, and at the end, after a bunch of other steps, you come to a threat intelligence. So based on this paper, they are claiming, again, I don't know how true that is because I was not part of the test, but they are claiming that we can predict cyber threats using machine learning. Again, remember how tiny the machine learning box was, right? It's not the whole picture. But based on machine learning, we can predict the cyber threats to 81.77% accuracy. 6,944 attributes were used, 600 instances were used, and 25% label training model was used. So, oh, that's great. But 80% accuracy, after going through all of this many steps, after getting experts and all of this, are we okay with 80% accuracy? I don't know. I mean, that's a question our organization has to ask. Yeah, maybe it's better than a human effort. I don't know. We need to compare that. So I have a few slides that at the end, what we found in my research, what I found in my research is that there is no standard framework. I cannot hire a college kid and say, okay, here is the machine learning framework, go learn it, take a boot camp and get trained, and come, I will hire you. There is no such thing. There is not enough rich data. I cannot go to Target and Facebook, hey, give me all of your data, now I want to train my model. That's crazy. I can't do that. There is no data available. Not enough experts per domain. Again, I was really looking. I don't know, go home and try on LinkedIn, machine learning and cybersecurity. How many people practice that? It's hard. It's hard to find experts, right? I'm not an expert. I need to learn, right? There's not a standard feature set. Nobody has done a paper that, okay, if you want to look for email that's a spam or not spam, these are the only set of features you will look for. Right? Our life is complex. It's not simple. Not enough computational power, memory to process ton of data. These are terabytes of data, right? We need to have a very, very strong computers. Not enough training time. Nowadays, we want everything easy and quick, right? Boom, 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 we are done, right? So who has time? We don't have time. We're all running. Not enough customization and blocks and algorithms. So this was interesting. I read this one paper, and then they said that, okay, now I'm smart. I already talked about the algorithms. I already looked at the standardized models. But what if I want to change classification blocks or regression blocks? Well, there are a lot of frameworks, like Google has a framework, Microsoft has a framework, but you cannot customize it. You cannot go inside and start coding and change it. So a lot of shortcomings, I guess, or maybe improvement opportunities. Another awakening moment I had was that models does not learn on its own. So a lot of claims people make that, oh, once you install us and once you are with us, you are good to go. That's not true. You can't, it's like a baby. You need to take care of the baby. You need to constantly train them, take care of them. It's like that. You have to continuously train your model. The model does not give us 99% accuracy. So we need to have a mindset, what will give me that accuracy and what am I going to be happy with? Once a model is trained, we need to keep retraining. I already talked about that. And yeah, it needs a continuous learning and shifting, and still not at the level of production. So I would say that in our industry, all of these people have worked very hard. The vendors have worked really hard. They are trying to come up with a solution, but I would say we are not there yet. We still have a lot of questions to answer. I know we live in a messy world. Like, I don't know. So I buy, I don't know, I think a lot of people will have Qualys, right? I work with Qualys a lot, right? It spits out millions of vulnerabilities. Okay, well, that's great. Thanks for making me feel bad that my environment is so bad. But how am I going to prioritize this? I have no idea. So at least something is better than nothing. These vendors are doing a good job. They are still doing a lot of research. There are a ton of academic papers. If you want to read it, please go ahead and read it. But I think we are not there yet. I think that's the crux of it. And I think that's it. I'm doing my further research on how do you compare. So and I don't know, maybe next year I will present on this, because I don't know, how do you compare two different ML solutions? If both people are saying that I am better at network attacks identification and response, how do you deal with it, right? How do you deal with ML in a cloud? So maybe these are future topics that I will continue to explore. But I really appreciate for your attention. I cannot believe you guys at Friday evening took a time and listened to me. So I really appreciate that. Thank you so much.